if you're solving this sine x equals 0.75, graphically what we did last time, you could graph sine x, right? If you have a graph of sine x, and that's one period there, and then you could graph 0.75, which would be in there somewhere, and then you look for the solutions like this, right? And we'll check it with the graph after to see what the solutions are. We'll check to make sure we've done it right. Algebraically is going to be using inverse functions. Just the way you have, if you have x squared equals something, you use inverse functions, square root of that, right? Or if it's, if it says x plus 7 is something, you use inverse functions, 10 minus 7, right? Minus instead of plus. If it says sine x equals that's somehow we're going to use sine inverse here, right? Sine inverse of 0.75, that's actually going to give us the reference angle, x reference. Remember that there's a whole bunch of angles that it could be. We're going to look within this limited domain first, and then we're going to give kind of the general solution if x could be any number possible. To find the reference angle, just use that sine inverse. The calculator is going to give you the reference angle when you put the ratio in, the positive ratio in. So things to make sure here. Make sure your calculator is in radian mode. And then find that reference angle, right? Sine inverse. We're working in radians. That's the ratio. It's going to give you the angle. The hard thing for people is the ratios and the angles look very similar. In grade before this, angles looked different because it was, 72 degrees or something like that. These look similar, and it's easy to get mixed up. If it says sine x equals, actually let's take a picture of that so we can write on it. Okay, so make sure you realize which of those things is which. Which one's the angle, which one's the ratio. Oh, don't have to do the inverse. That's good. I didn't push the inverse. You're right. Let's try again. You're right. Oh, you copied it down? Are you whining, or are you whining because I made a mistake? People make mistakes, You're not impressed that I made a mistake? People never make mistakes. Teachers aren't supposed to make mistakes. It's hard to talk and actually do something at the same time, Sine inverse of 0.75. Sine inverse of 0.75, actually, I'd like to say I did that on purpose because the numbers look the same, right? 0.68, 0.84. It's easy to get mixed up with what you're doing. Whereas if it was working in degrees, you'd probably catch yourself more because the answer wouldn't look anything like what you're expecting. Sine inverse of that, this is 0.85 radians roughly. Okay, now we will take a picture of that and do this, hopefully, with some success there. All right. Oops. Make sure you realize what's what here. This is the ratio, right? That's the ratio you were given. This is the angle here, right? That's what you're looking for. It's a number. It's a number, but it represents the possible angle. We're getting away from thinking of it as angles because we're looking at just as a function over here, a graph, right? We're not even thinking of rotating around anymore. That's a number, but that's the x, right? This is the reference angle, x reference. You can use that to find the possible solutions within here if you want. How many solutions are there going to be within 0 to 2 pi? You can think about the graph to help you answer that if you want. If you graph just one cycle of this between 0 and 2 pi, and then you look at 0.75 here, somewhere in there, there's going to be 2, right? There's one here, which is a reference angle, and there's one there. There's one in quadrant 1, and there's one in quadrant 2, right? Sine follows the y-coordinate. It's positive here and here. What you should notice is that this value here is positive. Okay, it's a positive value. Therefore, look in quadrant, another space here. Look in quadrant 1 and 2. let's dispense with the Roman numerals 1 and 2. Okay, you're looking at quadrant 1 and 2. There's going to be two angles you're looking for. Whether you're thinking of this or whether you're thinking of the graph, it's going to be quadrant 1 or 2. Sine is positive above. Right? Sine is above the x-axis for the first two quadrants, and then it's below. So you need to find two angles. One of them is going to be this. One of them is going to be the reference angle itself. Right? x1. I'm going to call it x1 and x2. Okay, one of them's going to be quadrant 1, so it's going to be that value itself. 0.85 if I'm doing 2 decimal places. If you want the other one, it's going to be in quadrant 2. It's going to be right over there, right? How do I find that one? Yeah, subtract it from pi, right? The way you find it indirectly is you go all the way around to there, pi minus that. All right? Subtract it from pi, so pi minus x reference. Or in other words, if we should actually say we're rounding it off here, roughly equal to. Go to the calculator and find that. Probably the best thing to do is store this. Store it as something on the calculator, and then you can use it over and over again. I'm going to store it as x. That's the reference angle. And then I can do pi minus that, pi minus the reference angle. Then I can just put x like that. The store button is over here next to the 1 on this particular calculator. There's ways to store it on lots of different calculators, because then you don't have to put that number in again. 2.29, angle in quadrant 2. 2.29. I'm going to take a picture of that calculator screen again, so we can refer back to it here. Okay, questions about that? I know it seems like you're not really doing it algebraically because you're using the calculator more than anything. When we get to ones where you have to isolate it first, yeah, you're doing some more algebraic operations first. There are two possible angles that it could be. Think about what you're doing. If someone says sine of x equals 0.75, there's two possible answers. Right? There they are. There's 1, there's 2. In the end, you should probably say x is either one of those numbers, right? You can say, I'm going to have to put it down here, but x is roughly 0.85, or it's 2.29. If you're looking between 0 and 2 pi. If you're looking, so this goes up here actually. If you're looking over all of the real numbers, as in no restriction on x, right? If there's no restriction on x, it's more than just these two values then. If there's no restriction on x, how do I find the rest of the solutions here? You need to think about the graph for that. So you have this graph of sine here, and it keeps repeating. If 2 pi is right here, that's 2 pi. Your first two solutions are right here and here probably, wherever 0.75 is. How do you get to the next one here? How do you get to the next solution here? How is that related to that one? Add 2 pi, right? Add the period of this graph, and the same thing for the other one. You could add 2 pi to get to that one. The general solution is then going to be, and again I should say roughly equal to. I don't know why I'm so useless at writing these kind of things. Roughly equal to. Take my time with it. 0.85 plus multiples of 2 pi. Hopefully we're good at this by now. 2 pi times n, where n is an integer. Or 2.29 plus multiples of 2 pi, where n is an integer. That's called the general solution. All right. You could find the next one if you want, but there's an infinite number of answers, right? So the way you express it is you could do this. You could list the first few if you want to find the next one, and the next one, and the next one. But multiples of 2 pi you add on. All right? That's solving it algebraically using the calculator. You're using the calculator to come up with the inverse function here. to find the reference angle. That's how you start finding your angles. The other way you could do it is using exact value triangles, right? You could use exact values here to solve this one. Remember that if we're solving this algebraically, we need to first do that. Okay? Actually, I'm going to stop and do this here, but think about what your first few steps were there. If we're trying to isolate the x, start isolating that.